Okay. So shortcut method. Shortcut method to find particular solution. Solution. It is also called as the particular integral. Whichever you like, you can call it. So let phi of t acting on y is equal to f of x be a linear differential equation, then particular integral is given by is given by phi of d y p is equal to 1 upon phi of t acting on f of x. Okay, so we have just have to study how this phi of d acts on this f of x. So the word itself says it is a shortcut method, so of course we will have to use shortcuts here. And the shortcut is, I will define the type. By type I mean what is our f of x. So we will have particular type of f of x on the right hand side, and accordingly there will be a change. I mean, depending on this f of x, we will have to write down the solution. Say for an example, so we'll just write this remark what I said. Remark, and depending on f of x, depending on f of x, depending on f of x, we write the solution. Write the solution. Okay. So case number one, it says that case one, if f of x is equal to e raised to ax, okay, then 1 upon, look, what we had was yp is equal to 1 upon pi of d e raised to ax. This is what I have to check out. Okay, so if f of x is equal to e raised to ax, then yp is equal to 1 upon pi of t e raised to ax. This will be equal to 1 upon pi of a e raised to ax. So what is what we did here? Can anyone elaborate what we did here? Dhruv, what we did here? Yashovardhan, what we did here, 1 upon pi of d e raised to ax is equal to 1 upon pi of a e raised to ax.
So we substituted capital D by A.
So, and what is the significance of a? What is a?
Don't know, sir.
फिर कांस्टेंट
बट क्या है वहां पे, ए क्या है?
डेरिवेटिव
इज इट डेरिवेटिव? 1/5 of d acting on the function e raised to ax. तो x का जो कोएफिशिएंट है that is a. So if you are operating 1/5 of d on e raised to ax, d is replaced by a. Okay, this is what you have to remember. But there is a problem that if phi of a turns out to be 0, okay, so 1/0 won't be defined. So if phi of a becomes 0, then what we have to do is, then what I will do, I'll take the derivative of this. Then 1/phi of d e raised to ax is equal to, so look, what I will do is 1/5 of d raised to ax, I'll simply replace d by a. And somehow it is turning out to be 0. So in that case, what I will do is, I'll take the derivative in the denominator and then I will put a. So this will be phi dash of a. और जितनी बार डेरिवेटिव लोगे उतनी बार x ऊपर आएगा, e raised to ax. Now again this may happen that phi dash of a is also 0. A is equal to 0. Then what I will do, I will take one more derivative, phi of d e raised to ax is equal to, I'll take one more derivative in the denominator and that will be phi double dash of a, and two derivatives, so numerator x square e raised to ax and so on. So now what is your task? Your task is to remember this rule. E raised to ax अगर है, then what I will have to do, d is to be replaced by a. अगर रिप्लेस करने के बाद में 0 हो रहा है, then take the derivative of the denominator, numerator में x multiply करो. Again, if phi dash of a is also 0, then you multiply once again by x square and take the derivative of the denominator. So this is how the rule works. Example. Example number 1. Find particular solution of d square minus 5d plus 6y is equal to 3 e to the power 5x. So yp will be equal to 1 upon d square minus 5d plus 6 to 3 e to the power 5x. 3 will come outside being constant, 1 upon d square minus 5d plus 6 e to the power 5x. So 1 upon 5 of d e to the power ax. The value of a is 5. So whenever you look like this, e to the power ax has got to replace d by a. So 1 upon 5 square minus 5 into 5 plus 6. This 2 will get cancelled out. E to the power 5x. So that is e to the power 5x divided by 2. Okay. The denominator didn't become 0, so it was a bit easy. Even if the denominator becomes 0 somehow, still we can get to the solution. And the solution is find particular integral for d square plus 4d plus 3 y is equal to e to the power minus 3x. So yp is equal to 1 upon d square plus 4d plus 3 e to the power minus 3x. So I said that 1 upon 5 of d e to the power x. The value of a here is minus 3. So put minus 3 there. 1 upon minus 3 square plus 4 into minus 3 plus 3 e to the power minus 3x. What happened? So this is 1 upon 9 minus 12 plus 3. So 9 plus 3 12. This all turns out to be 0. So denominator 0 हो रहा है. So we have seen that अगर denominator 0 होता है 1 upon 0 is not defined. So I will have to change my strategy. Once the denominator becomes 0, multiply by x in the numerator and take the derivative in the denominator. So what I will write here, phi of minus 3 is becoming 0. So the derivative of denominator is 2d plus 4 और ऊपर x से multiply करो. Now again I will put minus 3. So x upon 2 into minus 3 plus 4 e to the power minus 3x. So that is minus 6 plus 4 minus 2. So that is minus x by 2 into e to the power minus 3x. This is our final answer.
So can you once again explain that?
Which one?
X upon 2d plus 4. I didn't understand that.
It is derivative. What is the derivative of d square is? 2d.
2, yeah.
d square 4d का derivative आता है 4 and derivative of 3 is 0. तो ये जो term था यहाँ पे ये वाला we have took the derivative of this here. Am I clear? Who was it?
Yes, sir. Yes, sir.
Uh, okay. So it is just the derivative. Whenever you are, I mean, after putting the value of a, it becomes 0. Quickly you take the derivative. और ऊपर x से multiply करो. अगर फिर से 0 हो जाता है, again you take the derivative and multiply by x in the numerator. That is the procedure to be followed. So you can try this now. Find particular integral for d minus 1 cube y is equal to e to the power x. Do it, you have 2 minutes. Anyone? No one. So yp is equal to 1 upon d minus 1 cube e to the power x. Simply replace 1 d by 1 and you can see that denominator becomes 0. So what I will do is I will multiply by x nature derivative. That will be 3 into d minus 1 square e to the power x. Now you replace d by 1. Again it is becoming 0, 1 minus 1. So again I will take a derivative and multiply by x in numerator. So 3 into 2, 6 d minus 1 e to the power x. Now you replace d by 1. Still it is becoming 0. So again multiply by x. So that will become x cube. And take the derivative of d minus 1, that is 1 e to the power x. Now there is no d, so no point of. So this is your final answer. So until that 0 vanishes, by that time you will have to take the derivative and go on multiplying by x in the numerator with it. Just a small remark before I go to the next case. The remark is 1 upon pi of d a raised to x is equal to 1 upon pi of d e raised to log a raised to x, which is also written as 1 upon pi of d e to the power log of a into x. So your answer in this case will be, anyone? Anyone? What is the answer? 1 upon 5d to the power log a into x.
Sir, 1 upon e raised to log a.
1 upon e
E
raised to log a.
So 1 upon log a into e raised to log a x.
Okay. The answer is whatever is the coefficient of x, that is what you have to replace. So 1 upon pi of log a e raised to log of a into x. I'll give you some example in your tutorial on this. Is to be held this week. So case number 2. So case 2 is that if f of x is equal to sine of ax plus b, or f of x is equal to cos of ax plus b, then replace d square by minus of a square. Again, here what is the significance of a? In e to the power ax, that was the coefficient of x in powers of e, the case number 1. But in this case, what is your a? A is the coefficient of x in the parenthesis, I mean inside the sine and cos. So x ka coefficient, whatever it is, minus of that square is to be replaced. So how the pattern you have to remember, I mean, you have to understand. Wherever there is d square, only that you will have to replace. D will be remaining as it is. I mean to say, like if I want to replace d cube, then that will be d into d square. So our answer will be d square is replaced by minus a square, so minus a square d. If you want to replace d raised to 4, that will be d square square, which is minus of a square whole square. If you have d raised to 5, then that will be d into d square square. D square is minus of a square, complete square is a raised to 4d. So this is how you have to replace, and you have to keep d as it is. And to eliminate d, eliminate d, rationalize, rationalize the final expression. Expression. Before explaining this, I'll just write down 1 upon phi of d square sine of ax plus b. This will be 1 upon phi of, I said that d square is to be replaced by minus of a square sine of ax plus b. But even in this case, it may happen that phi of minus a square is 0. So if phi of minus a square is equal to 0, then take the derivative, numerator में x, phi dash of minus a square sine of ax plus b. Now still if phi dash of minus a square is 0, phi dash of minus a square is still becoming 0, then what I will do? I will again take the derivative and multiply the numerator by x. So that will be phi double dash of minus a square sine of ax plus b. This is what we have to follow until and unless that 0 in the denominator goes off. Example. Example. Solve d square plus 2d plus 1 y is equal to 4 sine 2x. What is important to understand here is the question is solved, which means that I have to find the complete solution. For a complete solution of this linear differential equation, y is equal to yc plus yp. You have seen that. For a non-homogeneous linear differential equation, our solution is of the type yc plus yp. In the previous questions, it was asked that just find the particular solution. Then we just found out yp. But in this question, it is solve. So whenever there is solve, we will have to find both. So what is the auxiliary equation in this? D square plus 2d plus 1 is equal to 0. So this will give me d is equal to minus 1
0.
and minus 1. Now roots are real and repeated. So yc is equal to c1 plus c2x e to the power minus x. This we have seen. Whenever there are the roots real and repeated, so you will have to take c1 plus c2x. Now What about yp? Yp is equal to 1 upon d square plus 2d plus 1. You have 4 sine 2x. So 4 will come outside, and what we have, 1 upon d square plus 2d plus 1 sine 2x. Now sine 2x is there. The value of a is this. Please make sure. Value of a is 2. So d square will be minus of a square. So d square will be replaced by minus of 2 square, which is minus 4. So this will be 4. 1 upon d square is replaced by minus of 4 plus d as it is plus 1 sine 2x. So what we got? 4. So 1 upon minus 4 plus 1 is minus 3. So this is 2d minus 3 sine of 2x. What do we mean by rationalizing? I've just said 2d minus 3 आया, so I will have to multiply and divide by 2d plus 3. So we will have 1 upon 2d minus 3 into 2d plus 3 upon 2d plus 3. Look in the denominator what you have got, a minus b and a plus b. So a minus b, a plus b will be a square minus b square. So I'll go to the top of this page and I'll rub this part of it. Huh. So this is equal to 4 2d plus 3 upon a minus b, a plus b, that is a square minus b square sine of 2x. So this is equal to 4 into 2d plus 3 upon 4d square minus 9 sine of 2x. Now what I can do is I can replace d square by minus 4 once again. So that is 4 into 2d plus 3 upon d square minus 4, that will be minus 16 minus 9 minus 25 sine 2x. So this will be 4 upon 25 minus sine. I will open the bracket to d sine 2x plus 3 sine 2x. So minus 4 by 25. Derivative of sine 2x is cos 2x. 2 cos 2x, so this will be 4 cos of 2x plus 3 sine 2x. This is our final solution, yp. So I hope it is clear. So whenever there is cos and sine, you will have to do this much things in order to get the correct answer. Fine. Second. Oh, I just forgot to write down. So what is the solution now? This is your yp, and the solution is y is equal to c1 plus c2x e to the power minus x minus 4 by 25 4 cos 2x plus 3 sin 2x. This is your final solution. So whenever there is a question which says that solve the given differential equation, you will have to find out these many things. You will have to find yc, you will have to find yp separately, and at the end you will have to add them. Next question is, find particular solution of d cube y by dx cube plus 4 dy by dx is equal to cos of 2x. It will be better if someone try. I could just convert it. That will be d cube plus 4d y is equal to cos of 2x. The particular solution is asked, so yp is equal to 1 upon d cube plus 4d cos of 2x. I want someone to solve it.
फिर डिनोमिनेटर 0 आ रहा है.
अच्छा, किसको डिनोमिनेटर 0 आ रहा है? Who is it?
Sir, me.
Uh, Shaunak.
Yes, sir.
Okay. What have you replaced?
सर d इंटू डी स्क्वायर किया और डी स्क्वायर को -4 से सब्सटीट्यूट किया, फिर -4d प्लस 4d आ रहा है.
अच्छा. Okay.
यस सर, 0 आ रहा है.
Huh. So then what you have to do if it is turning out to be 0, then
5 dash
डेरिवेटिव.
take the derivative in the denominator. Ah. So what we will have 3 d square plus 4 और ऊपर आ जाएगा x cos of 2x. Now you replace d square by -4, so that will be 3 into -4 plus 4 cos of 2x. So that is
x
12 minus 12 plus 4 minus x by 8
minus x.
cos of. Very good. So I hope it is clear now when what you have to do, right?
Yes, sir.
Now I'll go to the next one. Uh, the next remark says that this is case number 3. It is not actually a different case, but still I'm giving it a name. 1 upon phi of d square cos h of ax plus b. So that is 1 upon phi of a square cos h of ax plus b, and 1 upon phi of d square sin h of ax plus b. That will be equal to 1 upon phi of a square sin h of ax plus b. Does anyone know what is this sin h and cos h? Do anyone know what is sin h and cos h?
No, sir.
No. Okay, so this is taught in actually M1. I didn't know about diploma syllabus, but this sin h is sin hyperbolic. जैसे कि when you say sin and cos, those are defined using circles. Okay, मतलब if you go into the basics, those are defined using circle. These are hyperbolic sin and cos. Okay, so the sin h is sin hyperbolic, cos h is cos hyperbolic, and when you apply 1 upon phi of d square on cos h, the d square is simply replaced by a square. Okay, everything else is just like the case number 2. A small change is there, that there you were replacing d square by minus a square, but now you simply have to replace d square by a square. That is the trick over here. कि हाइपरबोलिक दिखा है तो डी स्क्वायर को ए स्क्वायर से रिप्लेस करो. इफ देर इज नो एच, then replace d square by minus a square. That's it. So I won't take a different example here. uh, I would like to spend some time on the next one. Hmm. This is case number 4. If f of x is equal to x raised to m, then yp will be given by 1 upon. Devendra, please mute yourself. 1 upon phi of d x raised to m. And why I'm doing this, I mean 1 upon phi of d, is because there is a very special thing about derivatives of x raised to m. Can anyone tell me what? What will happen to the derivatives? What will happen to the derivatives of x raised to m? Can you observe something? Sai Patil, can you say something about this? Is not there. Yes, Ashutosh Sathe, can you tell me something about derivatives of x raised to m? Say, let's not talk about x raised to m. Simply tell me about x cube. What will happen to the derivatives of x cube? No one.
mx raised to m minus 1.
That is just one derivative through. Uh, I want to ask, if I go on taking derivatives, what will happen? And say simply talk about x cube. What will happen to its derivative if I go on taking derivatives of this x cube?
x raised
If
to
you
m
don't know,
minus
then
n,
let's see. Yes,
x raised to m minus n.
m minus n.
Um,
No. Okay, let's do it. Say x cube. This is your y. Take the derivative of this. That will be 3x square, right? This is your first derivative. What will be second one?
6x.
Anyone?
6.
6x.
6. Third derivative is
6.
6. Fourth derivative is
0.
0. So we will use this trick. I mean, whenever there will be x raised to m, I know that after certain number of derivatives it becomes 0. So I will try to write down this phi of d in terms of derivative. Okay, we will write 1 upon phi of d as the series of derivatives. Okay, this is what we have to do. And how we are going to write this down is the series of derivatives is using just two series, and that you will have to remember. So I will write those series as a remark. Remark number 1 says that 1 upon 1 minus x is equal to 1 plus x square plus x cube, so on. It goes up to infinity. And the second one says that 1 upon 1 plus x will be equal to 1 minus x plus x square minus x cube, so on. So this is the series we have to use. Say I will just try to explain by a small example. How do you use it? Say what I have to find, say 1 upon d square plus 2d plus 5 times x square. This is what I have to find. What I said, 1 upon phi of d, I will write it down in a series. Look here. 1 upon phi of d, you will have to write it down in a series form. और series किसके लिए है? 1 plus x के लिए है, 1 upon 1 minus x के लिए है. So what I will do is I'll take 5 common in the denominator. So what I will have, d square plus 2d divided by 5 plus 1 x square, which say I'm calling this x in this, I mean say capital A. What will be the series of this? 1 upon 1 plus a, 1 by 5 outside in the bracket. Use 1 upon 1 plus x series. The second one, what we will get? 1 minus d square plus 2d divided by 5 plus d square plus 2d divided by 5 square dot 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 to infinity x square. How many of you are clear with this step, or you have any problem? Everyone clear with the step?
Yes, sir.
Yes. Shaunak is clear. Dhruv, are you clear?
Yes, sir.
Yash is also clear. Okay. So now I want to ask you, after how many derivatives this x square will become 0? How many maximum derivatives you can take of this?
3.
3? No. जितनी पावर है उतने ही डेरिवेटिव होंगे. At the third derivative it will become 0. तो मुझे d raised to 3 नहीं आना चाहिए. d raised to 3 निकाल देना है इसके एक्सपांशन में से. So what I'm doing is 1/5 आ जाएगा ऐसा का ऐसा. ठीक है. Now in the bracket 1 minus d square plus 2d divided by 5 as it is. अब ये expand करो पर I'll do the expansion in the here and at the top of this page I'll do the expansion of this d square plus 2d plus 5 square. So what do we have? D square plus 2d by 5 and there is a square. So when you square it, denominator will be 25. A plus b whole square is a square, मतलब यहाँ पे हो जाएगा d square का square plus 4d cube what is the last term? 4d square. ठीक है. अब x square का फोर्थ डेरिवेटिव हो जाएगा 0. So I can remove this term. D cube third derivative of x square is also 0. So I can remove this term. There is just one last term d square. D square is not 0. So इसके आगे come at the bottom of the screen. So there I am writing just 4d square by 25. And I can see that आगे की power 3 है. So leave it. All of them will be 0. Is anyone having doubt at this stage?
No, sir.
No. So now just open the bracket, take the derivative, and that is the final answer. So I will write down the solution here. So this 1 upon d square plus 2d plus 5 x square. So on the right hand side 1 upon 5 was there. If I open the bracket, I will have x square minus d square plus 2d on x square, and there is a 5 in the denominator, plus 4 by 25 d square acting on x square. So you can take the derivatives now. So 1 upon 5 in bracket x square minus in bracket second derivative of x square, that is 2, plus derivative of x square is 2x, so this will become 4x divided by 5 plus x square is the second derivative to 8 by 25. This is our final answer. Done?
सर लास्ट स्टेप में आपने क्या किया, फिर से बताएंगे प्लीज?
आई हैव ओपन द ब्रैकेट, मतलब ये जो डी स्क्वायर प्लस 2d है ना, बाहर एक्स स्क्वायर था, डी स्क्वायर आई एम राइटिंग ऑन द लेफ्ट हैंड साइड टॉप कॉर्नर, 2d एक्स स्क्वायर। अब इसका ब्रैकेट ओपन करो, ये हो जाएगा डी स्क्वायर एक्स स्क्वायर प्लस 2d एक्स। डी मतलब क्या है, डेरिवेटिव है, तो एक्स स्क्वायर का 2 बार डेरिवेटिव लेना है। क्या आएगा, पहला डेरिवेटिव आ जाएगा 2x, सेकेंड डेरिवेटिव आ जाएगा 2, तो ये हो गया 2 प्लस, अब डी ऑफ एक्स मतलब एक बार डेरिवेटिव लो एक्स का, डी ऑफ एक्स स्क्वायर, एक बार डेरिवेटिव लेना है एक्स स्क्वायर का, तो हो जाएगा 2x, 2 इंटू 2x। तो मैंने क्या लिखा है यहाँ पे, 2 प्लस 4x, ये देखो यहाँ पे।
ओके। ओके सर, ओके,
तो
समझा समझा।
नाउ find the particular integral of d square minus d plus 1 y is equal to x cube. Who will try this? You just have to find particular, so yp is equal to 1 upon d square minus d plus 1 acting on x cube. Do it and find out the final answer. Anyone? So what we will have here, series expansion 1 plus d square minus d. So put it a.
One.
So 1 minus d square minus d plus d square minus d square minus d square minus d cube, आगे डॉट 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 x cube. अब कितने पावर तक के रखने हैं और कौन से?
It
थर्ड
will
पावर तक रखो.
be plus d square plus 2d raised to 3, right?
Which one?
The
हाँ, that we have to simplify ना. तो थर्ड पावर तक रखना है हमें, that is clear.
but it will be minus sorry, it will be plus, right, over between d square and d cube.
No, it is correct. Alternate plus minus signs are there.
Okay.
So what we will have is d square minus d plus If you square this, you will have d raised to 4. And let's do it on a rough. D square minus d square. D raised to 4 minus 2 d cube plus d square. So d raised to 4 won't be there. Only 3 derivatives, will survive, and the fourth is 0. So that will be minus 2 d cube plus d square minus a cube. We have seen that a minus b cube. So d square ka cube will be the first term minus 3 d square square into d plus 3 d square as it is, and d square and minus d cube. I hope expansion is clear. This is 3 into 2, 6. This won't be there. Yet d raised to 5 is there. This also won't survive. Yet d raised to 4 है. Fourth derivative of x cube is also 0. Just one term is there, that is minus d cube. Minus d cube. And आगे सबकी power 4 है, so we will leave it. Everyone clear up to this? Now just
Sir,
हाँ.
sir, we have received the lecture link for 11:45 also, so we have to join that.
Wait a bit. It is
Okay,
about
sir.
to end. About to end. So just open the bracket. So that is x cube minus second derivative will be 6x plus 3x square, then minus third derivative is 6 plus 6x plus third derivative is 6 plus 6 minus 6 plus 6x minus 6x x cube plus 3x square. That is the final answer. Fine. Derivatives you can check out later if those are correct or not. So I'll stop here.
Okay, sir.